Okay, following on from our last video tutorial where we introduced the idea of sequence, we're going to now go on to Chris's next finger of computation, which is decision. Can't do much with computers if we can't make them make decisions. So what we're going to do is we're going to make a decision about the colour of this ellipse. Okay? So we're going to draw one of two ellipses based on some decision we're going to make. So the structure for decision, or an if block in a computer, consists of the keyword if, which we'll see highlighted in orange, a couple of regular brackets, which is where some kind of decision's made, that's where some Boolean comparison between two things, is it equal, is it greater than, less than, something like that happens. And then we have some curly brackets, which in the simplest case contain what happens if this resolves to true. So if 1 is equal to 1, which we're all pretty confident it is, this thing down here will happen. Okay? When we're doing testing equality, we use double equals, so that's something to check when you're doing this. So let's just try that. If 1 is equal to 1, draw my ellipse. Okay? So it's all good. 1 is equal to 1, the ellipse is there. Close that. Now I can change that. If 1 is equal to 3, which I think we can all agree is not true, when we run this, we can see our point in the middle, but this piece of code has not been executed, the bit inside the brackets, because this does not resolve to true. So what happens if this is not true? We can use a thing called an else block, which is just another part of the if statement. So now we've extended it. If this thing resolves to true, we're going to draw an ellipse. If this resolves to false, we're going to draw a rectangle. So the function for rectangle is rect, and this expects an xy position, a dimension, a width dimension, and a height dimension. So let's run this. So just now we're going to come through this code in sequence, test this case to see if it's true or not, and it's not true, so the second thing in the if statement is going to happen. We're getting a rectangle instead. Okay. So now we can introduce something a bit more dynamic here. This doesn't have to be a comparison of two static things, two numbers, two variables, or something that we're going to just give to it. We can test some input. So last time in the assignment, we used the mouse. So what I'm doing just now is I'm just commenting out this code. If we use a star and a slash, and then a star and a slash the other way around, the computer program is not going to interpret this. It's going to assume this is a comment, this is some description or annotation. And it's a really good way to just, when you're developing things and playing with them, block something out. So instead of rendering my point in the middle, I'm going to render my point where the mouse X and the mouse Y is. Okay? So if I run this now, we should get something akin to the very first. Okay, sorry. Blast. I need to put this inside a while loop to make it happen. No, I don't. Okay, sorry, we need to extend our code a little bit here. Because we're wanting to use some animation and some things to iterate, we're going to need to introduce the setup function and the void draw function. Okay? So all these are doing is saying this function is called the first time it's ran, and the Apple T to get it all nicely indented. The first time the program runs, this function is called. The second time, every other time the screen refreshes, this function is called, and the code in there is executed. So this is us just getting a little bit of interaction and animation going on. So what are we upset about? Okay, I forgot to tell the setup function that this is a void function. Okay, apologies. So now we should get something very close to the first thing that I showed you in class. So we video explaining how to get to this. Okay. But I don't want to just draw with that this time. I want to make a decision based about where the mouse X and the mouse Y is. So I'm going to bring back in my decision code and do Apple T again. It'll get us all nicely tidied up. So I need to make a decision inside these regular brackets, and I'm going to say if mouse X is greater than width divided by 2, So if the x value, the one lengthways left to right, is greater than half of the width, so if we imagine this as our box, so if the mouse is in this side, this should resolve to true, and we'll see an ellipse. If the mouse is in the other side, if the opposite of this is, if this is not true, if this is false, we'll see this thing being rendered, okay? So let's just play that and see what happens. We should get our points drawn all the way along as well. So we know that our code's working. We're in the left-hand side of the screen, so we've got a rectangle. If I move over here, oh, we get our ellipse. And what's going to happen now is, because we're not refreshing the screen, these will just keep drawing over each other. So I've got my rectangle at the front, ellipse on the front, rectangle, ellipse. Another thing we could do if we want to come away from these shapes is we could, as we learned this week, control the colour of the stroke. So if I go stroke, let's make it red, so 255, because we're just in the default settings. No green and no blue, so I want all the red on, no green, no blue. And if I'm on the other side, I want to be green. So what we're going to be able to do now is, when we move our mouse about on the screen, the colour of the thing we're drawing is going to change. So I think that's maybe just been underneath. The colour of the point that we're drawing, which is kind of hard to make out, let's just zoom in a bit. The colour of the point we're making is going to change based on where we are. And if we go slowly, you can see that's working not bad. Okay, so this is our second finger and our four-finger introduction to programming. We know that things happen in sequence, and we can control branching or decision by using if statements. Okay.